Hello, and welcome to a conversation that I have been looking forward to for quite a few days now, and I'm seeing quite a lot of interest on social media, so I know that quite a few of you joining us today are excited to talk about breaking the human code to modernization. Now, chances are, if you're on this call, you have been working on modernization for a while. At the danger of dating myself, I worked on the first modernization program of my career over 20 years ago, when modern meant something very, very different to what it meant today. And yet here we are, still doing modernization work, still hearing about modernization projects, still on a process that seems to have started a very long time ago. Why are we still doing it? Did we not do it well enough? Are we not done? Or is it that the goalposts keep moving? Arguably, most of the modernizations we worked on in the past succeeded. And yet here we are doing more of it. Each modernization seems to be harder than the one before. Each modernization seems to be plagued by difficulties. And there are all these statistics and reports that we see about the very, very, very high percentage of failure in modernization, particularly in financial services, but also beyond. So what we're here to do today is acknowledge why modernization is hard, look into some of the reasons that we can do something about. We actually don't want to dwell on the failure modes. We want to look at the things that work, share experiences, share tips, share advice. And I have the most perfect panel for this conversation. I personally have about 3 million questions for them, so the time we have will barely be enough. We have Q&A that will be open throughout the session, so please use the questions tab and send questions as you go. I will be keeping an eye on them as the conversation with our panelists progresses. And I want to start with a question that's on everyone's mind. Dil, I'm going to start with you. Modernization is hard. We keep doing it. We keep struggling with it. We keep needing to do it again and again, even when it has succeeded. And we all agree the biggest challenge is human, not technical. Why is it so hard?
Thanks, Leda. Hi, I'm Dil Aujla, work for Thoughtworks in the European Modernization Group. It's hard because it starts with different forces. So the different forces have different needs in any given organization. There could be the finance department, the technology function, the governance and compliance functions. It starts, as most people have experienced, through the theater of the budget setting exercise. What's the business case? What's the ROI? Are the costs going to be X? Will the returns be Y? And most people know we call it a little bit of a theater because you have to say the numbers to get the investment and the budget back from what you're trying to do. So that starts in expectations. The expectations have to be governed, and we start that cycle. So it depends on who wants what and how unified they are in what they're trying to do. And so when we say it out loud to anyone on this call, it sounds very, very obvious, but we know in practice those forces can diverge.
They can, and they do. And I take some comfort in that that's just not our industry, but actually across the board. And David, you work across multiple industries, and I'm going to ask the question that I get asked a lot by people who are not knee deep into this. We have the best technology we've ever had before, arguably living in one of the most exciting moments of human evolution. You see this journey, this struggle, this work across many industries. What do you see that works well? What brings faster progress?
That's a great question. So, David, Group Product Manager at Google Cloud. I think that even the best technology in the world can't overcome a flawed strategy. And lessons that we see from high-velocity sectors is that they view modernization as a strategic program, not just a tech project. We need to be value-driven and organizationally aligned, and of course, AI accelerated so that you can move as quickly as possible. And also, I think we see from customers that the right way forward is not to think of mainframe modernization as this big bang approach or a complete migration necessarily, because industries rarely succeed with that. Instead, we aim to, what we guide our customers and what we see our customers succeed with is not to view the mainframe as a monolithic block to be replaced, but instead treating it as a set of services that can be peeled off, asking maybe which 5% of these mainframe processes or application that, if modernized, will bring us 80% of new value. And also, I think that we see from our customers that if they set up the modernization journey and project correctly and set up a COE or this digital transformation office, maybe that has its own P&L accountability, direct executive sponsorship, we see that as a key catalyst for success. And of course, using AI to accelerate every phase of the modernization lifecycle. But it's not just technology, it's technology and baked with the right methodology as part of the process.
Which is the perfect cue to bring Edward into the conversation. It is technology in combination with a problem that we've matured to understanding, and now AI is in the mix. Edward, thank you for being with us. In the context of everything we've heard, what is new about the way you guys approach this? What is the Mechanical Orchard posture in this problem statement?
Yes, thank you, Leda. Edward Hyatt from Mechanical Orchard. We're working on perhaps a novel approach in the industry for how to take on this sort of age-old problem of the modernization of the very legacy. And as has been said, this notion of legacy modernization has been thought of as a big, hairy project historically, generally speaking. Shall we go and modernize this system? Which I think, as Dil said at the beginning, already is kind of off to an odd start in the conversations that I witness at customers. Meaning, in some sense, all code having been written is legacy, right? We're constantly working with legacy systems. And so from an IT point of view, well, when is it that the modernization should take place? Is it when the system is 1 year old, 10 years old, etc.? And it tends to become a decision based on technology pressures, perhaps budget pressures in IT, that are divorced oftentimes from the actual business need, right? So how does one bring together this notion of incrementally always modernizing and attaching to the business? I mean, that's where my summary goes in terms of how people are dealing with this problem in a new and better way. Our approach, in partnership with those on the call here, is very much to think of the correct mindset here, to rather than being a project-based approach where you're starting and then you're finished and you're kind of crossing your fingers that the big bang goes well, rather to embrace some sort of notion of continuous modernization, which is a term Gartner I know is championing the last few years. Meaning, how do you get to a place where the whole organization is comfortable living with a constant sense of legacy and new living together, and a constant pressure back and forth between the business and IT for what's the right priority in terms of spending time and resources in terms of modernization towards some business end, right? So that the classic situation being the business needs some innovation on some particular customer workflow, or a faster time to bug fix, or better uptime, et cetera, for some old system. That should be the kind of driver to determine the priorities of modernization. And then, is it the whole system that has to be modernized over some, tens of millions of dollars and 3-year project, or could it be some components, as David was saying, that we could start with, and then perhaps live in a situation where the new and the old are more comfortably operating together, allowing for agency in the business? Do we go modernize more old stuff, or have we got enough for now to solve the business need, and we can go and do agile development on the new stuff? So it's that notion of being comfortable somehow in operating new and old together that we see as sort of the way forward in this age-old problem, rather than this notion of, well, what's there to be modernized and what's new enough, and the IT decides, right?
The idea that all code is legacy about 5 minutes after it's written is both absolutely right and absolutely terrifying. Because the reality is nobody likes to think of that, particularly in the context that Dil described at the beginning of the institutions where I grew up working, where it will take us 5 years to make a decision and then another 10 years to build the thing. So we can't afford to think of it as anything other than for the rest of our working lives. But the reality you all just described is the reality we lived in. And David, I want to come back to you because you have started already, between the three of you, pointing to the accelerants that are available to us. But we do have a little bit of a hope from decision makers that some of this will be magic. It's not quite magic. But there is a little bit of magic and an accelerant that we never had before. So how should we be thinking about it, particularly for decision makers who are not deeply technical?
That's a good question. And unfortunately, it's not magic yet. We may get there one day. But we do live in very exciting times, I think, because we have this convergence of technologies that for a lot of organizations show a credible and a viable path forward. Combining AI for being able to reverse engineer the existing mainframe code base. We have products like our mainframe assessment tool that can do that, giving organization the clarity. A lot of them are scared scared of what they will find inside their mainframe code, decades old, right? So give them the clarity and the insights they need to reverse engineer, understand their business processes, and then determine which ones should be modernized, which one can be, and to what degree of modernization. Maybe some business processes require changes to be up to date with business needs. Maybe some are obsolete and you don't want to carry them forward with your forward engineering effort. But I think beyond that, it's not just AI. We talked about processes before and the right way to think of the modernization as old code living together with new code and peeling off services from the system. But I think a lot of concern we hear from leaders with the customers we work with is that they still view modernization as risky, and they want to reduce the entropy in it, and they want to de-risk the process that they can get some measure of ensure success. And one of the other technologies that we offer that works together with the Mechanical Orchard platform, for example, is our dual run solution, which allows the customers to run both the legacy code, the legacy applications, and the modern application in parallel to compare the outputs. And when you think about how do you de-risk the migration, how do you provide this reassurance and safety net before customers go live, I think this is a very important value proposition, because you can using dual run production traffic that's on the mainframe, live traffic, and send it to the modern application and compare the outputs that are being generated with the expectation that for the same inputs, you expect to generate the same outputs. Otherwise, you might have bugs in the code. And this focus on de-risking modernization combined with AI for acceleration, I think that really is a game changer for our customers. And we are excited to see what potential this can bring in terms of reducing cost and timeline, and also making modernization successful. And even though it's not magic, maybe it's the closest thing we have at present day.
It definitely is the closest thing we have. And I think if we could see our audience, there are several points in all that the three of you have said so far that you would have seen heads nodding, because you describe a reality that we're all in. Big Bang doesn't work. How do we know that? It has exploded in all of our faces at some point in our career. We all go through a bit of theater to get to decisions, because the main thing we're battling, as David rightly said, is fear. Fear that you'll make a decision that will leave you holding a baby you really don't want to be holding. Fear of what you will find. And behind closed doors, we hear of clients having outages because of a batch job that went wrong. And we all have all of those stories, right? So I want to stay with that for a minute. I like to call it the elephant in the room, but I think it's bigger than the room right now. The technology we have now, you're right, David, it's not magic, but it's the best we've had. But if I look back at the 25 years of my career, the technology was never this good, but the technology was never really the problem. It is not where we fell down. And the fact that the tech exists and it's scaled is great, but everything dies in that place of fear that you just described, between the rock of making a decision that isn't all known. It has some variables that require some courage, and the hard place of actually seeing it through, where we go back to the theater that Dill talked about. We make a 5-year plan, $100 million budget. We We find that stretching, taking a lot longer than planned, things spilling over, budgets going all over the place. So the minute we hear modernization as a decision maker, what you're thinking of is that never-ending time frame, the fear, the bottomless pit. It's giving me anxiety just thinking about it, just because of PTSD, right? So Jill, I want to go back to what you were saying earlier about the way we normally go around convincing people, convincing our stakeholders, that piece of theater that we all engage in that we know is theater, but we also know no other way. And I think we all agree that we do it because we understand the fear, we understand how organizations behave. Where are we now with everything that we heard? Now we have dual run, we have Imogen, we have mechanical orchard, we have solutions, capabilities, and experiences that should make it easier to change the conversation. Does it?
Yes and no, as any good consultant would say. We have still the art of managing expectations. So people will say, if we use this example, we have a new technology as an accelerator. Does that acceleration mean that everything is automated? So we know we're going to get something which is better, but is it 80% faster? Is it 90%? Or is it 20 or 30%? Within Thoughtworks, I think it's possibly the number one question I'm getting asked by people I meet, new clients, new prospects, is how much does AI change the software development lifecycle? How much does the output increase, or the efficiency, or the speed, or the reduction of costs? And the actual answers we're working for is that it's increasing all the time. It can be between 30 to 50% what we're seeing. David mentioned earlier a really critical point, that when we do things like dual run, we still have to monitor outputs. When you do iterative things that Edward mentioned, that we still want to check that what we're doing is an equivalence, because it's really important that we have equivalent functionality and equivalent rules. So there is an increase. When I ask people back, if we're at 30, 40%, what time do you think it'll be 70, 80%? And there's a range of answers, but there is a school of thought which says actually it may plateau at a certain point. It may say this is as far as it goes, because we will always need humans in the loop. We can't just run enterprise mission critical systems that hold an organization up and say the code was generated and no one looked at it, right? Just even for compliance regulatory reasons, it won't be. So it's actually saying, what's the real world saying, what's really happening over what people hope would happen. And I think I think we talked about some of the romance behind this. I know you may go on to this, Leda, but there is an element of what do you want to happen to what's the reality, and managing that really closely.
So a lot there. And I had a question that was bubbling up in my head. But before that, I want to ask a question from our audience. As you were speaking about that direction of travel, we had a question pop up from Dan saying, is that no human in the loop direction where we're going? And if it is where we're going, how does it affect what we're talking about now?
Yeah, one of my colleagues at Thoughtworks mentioned the concept of dark factories. I don't know how well known this is known, that where you can have now factories that can work without any lights, because the machines don't need lights to build cars or build other manufacturing things. But when you go onto the factory floor and a human walks in, the lights still come on. There's still a path for humans to tread, because sometimes the machines go wrong and someone will need to fix those machines. So my personal belief, and this varies, I'm not sure there's a right and wrong answer, because it's like trying to predict the future, is that we will always need humans in the loop. It's just how many and when. So if we have, I'm going to make up, if we had 8 developers on a project now, could we get away with 5 because we have so many good automation tools? We're working with Copilot, there's other accelerants and so forth, so we can reduce. Will that ever go to 0? My belief is no, because we still need to manage things that will impact people's lives, where it's a banking transaction, it's a hospital record. Allowing that to machines only, I just cannot see that area of governance happening in the next 5 to 10 years.
Well, that reassures me, and I'm pretty sure it will reassure Dan, who asked the question. If we stay with that theme, and I guess that's a question for both Edward and David, one more question that has come actually in a slightly different format from 2 different people in our audience is, this sounds great, almost magic, sounds great. The process side sounds familiar. The AI uplift and speed sounds inspiring. But if I do use a tool, a third-party tool, like what we've described earlier, like Imogen, or who owns the IP? And we did not rehearse this, boys and girls, so I don't know if Edward and David, you have different answers. But David, I'll come first to you and then hand over to Edward.
Yeah. So I just want to think that I just want to chime in 1 second, if I can, on the human in the loop question, which I think it's fascinating. And I just want to share from my point of view that what we actually have seen at the moment is that humans in the loop are critical when you look at modernization. We have seen a process that is AI accelerated with the right amount of human validation and checkpointing interjected into the process. For example, you reverse engineer some mainframe code to extract the business rules, right, that may have not been updated or even reviewed in very long time. And then you have a business expert, as me, go over those rules, validate them. First of all, gain insight a lot. In many organizations, we have seen this process uncover a lot of known unknowns and unknown unknowns about the business processes, but validates the rules manually, checks them to make sure that they are still aligned with what the business needs, how the business needs to operate, maybe add some rules and remove some rules. And this human validation of the business rule, I think, is essential to the next step, which is to actually modernize the code and create the most accurate representation of the business rules within the modernized code. Now, while this process has a human in the loop, there will be other jobs and other applications on the mainframe that perhaps could be more automatically generated. For example, using Mechanical Orchard's platform, where you can actually achieve functional equivalence. There would be processes where you don't want to touch the business rules, some processes where you do want to interject some changes. And I think this combination and the flexibility of how you can use AI for both a more automatic process for building and testing and looping it this way to ensure functional equivalence, and then having Duran perhaps in the mix there. But some applications, you do want to interject and check the business rules and maybe update them, right? So they're more aligned with business current business needs. So I think this is something that we see. So again, no, I don't think we are replacing people just yet. I just think we are changing the roles of engineers and business owners to be more of supervisors of the AI tooling that's generating the code and extracting the business rules. So you think of it as actually it gives people more sovereignty to control the process and orchestrate the process and influence the process, while you let the machine do the low-level thinking, code generation, business rule extraction that previously you also had to do manually. So it's a efficiency and productivity booster, I think, allowing you to accelerate faster and more cost effectively. And regarding the IP question, I think I will let Edward take that one.
Oh, cheeky.
Well, I will answer that one, but let me just step into this by referring back, maybe just to summarize what's been talked about the last few minutes, to what Dill and David have been saying about the human side of this, Leda, right? So the fear was quoted as being one of the problems with getting energy behind these efforts. And we've talked about, the notion that modernization is not a discrete notion, but rather a continuous one. Why are we saying that those two things go together? Why is that, iterative, incremental modernization, constantly ongoing, is a solution to this fear-based human problem? And it comes down to what was referenced a few times there, which is these efforts, right? Why is Big Bang a bad idea? Why have we failed in large part for the last 30 years to get off mainframes? It's not for lack of trying, right? It's generally because the confidence that the system that's been created in some new language, new framework, new technologies, right, may not have quite the same behavior as what you're replicating, right? And to the extent that those are very critical business rules, critical processes, lots of throughput, lots of money flowing through, take a bank as a canonical example, that is unacceptable. You can't really have a nervousness about whether you've written, changed functionality by mistake, right? There is massive inherent entropy in these systems, in these change management kind of programs. How does one collapse that entropy and thereby reduce the fear and build the confidence and get to a place where the notion of ongoing modernization doesn't sound like a fantasy or some consultant's pipe dream, right? But rather a practical state that you can always be in. And so this notion of equivalence, right, and the proof point that the new thing you've built mimics precisely the old or is different in the ways you expect, that we think is the way to collapse the entropy. And actually, if we can combine this notion of iterative development and equivalence and dive in on what that really means, we're talking here about teasing apart a legacy system, perhaps based on business priority, perhaps based on some logical grouping of components that make up some workflow or some process that's expensive to run or difficult to change, right? And for each of those components, capturing its behavior through data inputs and outputs recording, right? So what does this batch job do at 2 a.m.? Well, let's record its before and after data state for the last 3 months, 6 months, etc., and build up a library of test examples, which one can then, so to speak, push through the candidate implementation and see if it's right or not, right? In other words, rather than thinking of this problem as primarily a translation problem, which I think has been the natural, obvious way to think about it in the past, how do you translate COBOL to Java, right? And couldn't we use AI for that to do it faster? I mean, that's all yes. But the confidence in moving forward, I would say, is not that greatly improved by using AI to translate. In fact, it might be less confident because we famously, the language models hallucinate, undeterministic, etc. And if you don't understand the code base in the first place and its business rules, how can you be sure that the AI has gone and understood it and produced something equivalent? So all of that comes together in the approach we're advocating for being an incremental modernization approach, where you're proving the equivalence of a component by component transformation and putting new components live alongside the remaining legacy counterparts. So that's the kind of concept we're all talking about, to be concrete about it. And then as it relates to the use of AI, right? How can one harness this amazing moment we're in with generative AI promising to make that translation act much simpler, or language models in general being able to comprehend big spaghetti, hairy code bases from the last 60 years, which have been modified by different bands of teams over decades and different technologies. How can one harness all of that? It's interesting to notice that almost all the energy in the industry is about those two acts. It is about comprehending something very old and very complicated, and it's about translation, right? Or as David said, perhaps a way to say it differently is, how do we extract business rules using a language model and then generate new code that is nice and cloud native and readable from those business rules? It's a very core, important thing to generate readable code. Otherwise, you're going to end up with the same, JOBOL-like, Java COBOL, where you may as well have just done a Google Translate with every word in the COBOL, right? So that's what we're saying has to be rethought if you're going to pull off this provable incremental approach with data collection serving as the behavioral specification, and then it can be used to hone the candidate implementation such that it is provably accurate. And the simple answer here that, for example, our Imogen tool, Mechanical Orchard's tool, promotes, that's being used by Thoughtworks, that's being used effectively with GCP migrations, and it's working in concert with the technologies David's mentioned, MAT and dual run and so on, is that actually, if one can harness this data capture idea that I mentioned and build up a library of really tests, right, that serve to demonstrate equivalence or not, then one is in a position to actually take the latest AI innovations, right, and say, go to town, hair on fire, let's just push this Gen AI to its limit and see what it can do in terms of excellence and code quality, deduplication, etc., right? Knowing that we can't trust it at all, right? Or assuming we can't trust it at all. In other words, we're adopting a trust but verify, if I could say, approach where we don't trust the generated output, but we use the data captured specification to figure out where it's made a mistake. The business rules weren't quite right. There was a bug in it, etc., right? Or perhaps it fixed bugs that the old system had that we don't want to fix in case of integrations breaking, right? So how do we know it's exactly equivalent? We don't until we've pushed this old data through. And this use of AI in that way, right, I think solves for what we haven't mentioned yet, which is that the attempt to use Gen AI to produce new code is rarely seen as a safe thing to do in the industry. So when you hear people talking about this topic, right, what they're generally really doing is using LLMs to comprehend an old code base and then making an attempt at using Gen AI to translate. But because the translation can't be trusted for the famous reasons of hallucination and non-determinism, but really also because you don't really know what the old thing did necessarily. So how can you know what the new thing's supposed to do in any kind of human verifiable way? Rather, what you do is you retreat from Gen AI generally to more of a transpilation so-called approach, this word-for-word approach, so that you can more likely trust the output's behavior. But then you end up with really crappy code that may as well be still in COBOL in terms of maintainability, which is often a core reason to move forward in the first place. So how does one learn to trust the AI and harness its potential? We would say there is no way except for this data capture that proves or not at the low component level equivalence. And how it actually works mechanically, just to finish off, would be, from our point of view, the state of the art is Gen AI is getting better. Give it a chance, turn the crank to 11 and say, go to town, Gen AI, see what you can do with this 10,000 lines of COBOL, right? But then to assume in general, you're going to have mistakes the data flows will expose. And then what, right? Well, in some cases, you can actually have an agentic model fully automated where one agent is producing candidate implementations and the other is saying, oh, I've ran data through it and it's got different outputs, try again with this new context. And you can actually have a convergence happen in some cases, but the state of the art is not really there to do that more than, 10% of the time. Almost all the time, rather, you are having Gen AI make an attempt at a candidate, which may be beautiful code, maybe directionally correct, so to speak, but may have many problems. And the data exposes them. And then you have a human do some prompt engineering with the language model, and it helps it converge better and better on a solution, maybe with some just purely manual fixes near the end of that process to kind of asymptotically approach perfection, right? So that's what we think the state of the art actually allows for. A big swing is a good idea with Gen AI to get really good, clear, readable, human and AI readable code. But if you're going to do that, you have to have some mechanism of verification that is not humans checking it or AI telling you it's correct, right? So that's the insight, I think, to pull off continuous modernization, to actually incrementally modernize and reduce the fear. You have to collapse the entropy by showing progress and proof with data capture, pushing things back through the candidate implementation. And if you do that, you can also tell Gen AI, like, do your best, as opposed to retreating to this kind of Joe Ball situation, which ends up being sort of just a move to cloud for the sake of cloud, and you're in Java now or whatever language, as opposed to get the benefits of cloud native, which is what we're all trying to get. So that's a long answer, but I think it's important to get specific.
It's an excellent answer, and I want to collapse the entropy on a T-shirt now, because it is the rallying cry we need. But I think as you were speaking, and you painted a very, very vivid picture, and it's a very vivid picture in all the ways we need these pictures to be vivid, because one of the things that all of us live through on a daily basis is that level of abstraction when we're talking about how AI will be implemented to solve our problems that leaves you thinking, you don't have an answer for me, do you? So that was the exact opposite of that. You gave an answer that I want, before we go back to some of the questions we've got from our audience, I want to marry with what Dil was saying right at the beginning and what we have constantly come back to, that a lot of the decisions in this space are coming from a place of fear, not because decision makers are cowards, but because they're burnt. We've all been burnt in the past. Now, Edward, you built a picture that is truly differentiating from what we had access to in the past. And you described something that even people who have not really toyed with this idea before can actually logically work their way through and see that the risk log would look different. The time frame for this would look different. The amount of commitments I need to make today for what will happen in 5 years looks different. And that is both brilliant, but also challenging, because we have a very familiar dance we do when we're looking for budget that Dil described. So how can we help decision makers who just heard you and thought, I want what this guy just described, to translate that to some proof points that can go into how we normally think about our ROI, how we normally think about decision making? What are the proof points we can bring closer so that someone who hasn't been on this journey can sell this journey to their organization?
Yeah, I mean, I think the real result of what I just described, right? The outcome, to use the jargon, is that you're setting up a way in which the IT organization can operate much more at the service of business priorities, right? So, I think we can acknowledge in our industry, at least historically, but I would say contemporary companies look mostly like this still. We've got an ossification of the two branches of engineering between IT and the business need, right? And those two things, unfortunately, tend to be far apart. The notion of them being integrated sort of horizontally in the sense of a business plan exists to build some technology that will help the business with some goal, more revenue, more eyeballs, customer capture, different demographics being targeted, and so on, is generally speaking thought up in the lines of business. There are analysts there who have got business degrees, and they're thinking about the actual company business. But there is a vacuum, there is an absence of a cultural connection back to how are we actually going to pull this off in terms of building it, which is generally filled by a very traditional kind of spec-driven, throw it over the wall answer from the business people to the IT people. And while that all sounds very 1990s, and surely we're past that these days, I mean, frankly, that's the situation most of us find ourselves in. Yeah. So how does one, bridge this gap? And the answer, generally speaking, is what consultants would refer to as cultural transformation or integration of different functions, or some kind of coordinated efforts to collaborate better, but often ends up being more paperwork, more documents, more meetings, right? And so the key that I've seen work the best, right, is to force the issue on the business side, on all those analysts that are smart, right, to define success metrics from the business point of view, that this new software that's being imagined, new meaning greenfield, new applications, yes, but also improvement, more likely improvement of existing software. How does one measure the efficacy or the success of what that effort is bringing, right? Now, generally speaking, that's a question that is hard for people to answer. They're not used to coming up with very concrete metrics that say, if you build this, we expect this much more dollars in the door, or this many more eyeballs on a workflow, or this much more success in a checking account sign-up process or something, right? But if you can force that issue and get really concrete, especially if it's a continuous measurement, which many of these things, of course, are, it does provide some framework then to bring that desire back from the analyst through the product team, the architecture team, the IT team, the engineering team, the security and compliance team, etc. How are we going to do this for the sake of the business, right? And it gives the IT team a way of talking about, socializing, asking for budget around this continuous approach. Because the requirements are not monolithic in terms of go build this 3-year project that's this big application, or go change everything, or modernize this system so that later we can do that. It's much faster of a turnaround. It's much more incremental. Can you build this feature? Right? Well, I could build this feature if we just modernize that component. Okay, let's modernize that component so you can build this feature, so we can get these business metrics to go up and to the right, right? That's what I've found to actually break through these cultural ossification pillars, silos, whatever you want to call it, in the business. And that's what also can lend credit to this desire in IT to move towards what I'm describing as continuous modernization, but it's often so difficult to find a business case around on its own merits. Rather, if you can attach it to an actual business case and force the issue there. And I think, as we all know, that sounds like happy talk, and surely that would work. But, it isn't the case that we have very clear business metrics. It isn't the case they're broken down into incremental pieces. It isn't the case that the communication is through the business intent as opposed to a requirements document. It isn't the case that it's incremental. And so that's why I think we end up with this ongoing problem of how does one think about modernization budgets? Where's the business case? Because we're talking way too macro, way too monolithic, and way too siloed. Right? That would be my thought.
And that's I'm sure this is another moment where everyone on the call is going, yep, been there. And you have all hinted, I was going to say, but you haven't hinted. You've been very, very, very clear that we cannot transform this without making some changes to how we think about it in the business, because fundamentally the solutions have changed. We need to lean into them differently. And you bring to life something that really, frankly, should work, because it solves a lot of our own dysfunctions from a risk management perspective, budget perspective, a decision-making perspective. So let's assume we're in this glorious moment where we have found the use case that is standalone or fits in well with our strategy, that we rallied our decision makers. We have actually decided that the way we've done it before isn't going to get us anywhere, and we have the tools, we have the process, we're ready to go. We're seeing some questions come through from the audience saying, right, assume we're mid-implementation. What are we seeing in terms of classes of problems? What are we seeing in terms of behaviors and outcomes on systems? Are we seeing problems that are impossible or overly difficult? Are we seeing challenges and blockers to success with what we're describing here that boil down to teams' inability to understand or implement something? What are the next set of problems? I guess someone who's even more pessimistic than me or more realistic than me out there going, right, we got the approval. What are the next set of challenges we will need to overcome? Dil, I'll come to you with this first, but then David, if you can bring some examples around dual run, that would be great.
So one of the big challenges that teams face is the aspect that there's two systems to maintain. So in the way we've described, that Edward described, and David's talking earlier, we'd want to do things iteratively. So in that world, people are familiar with the strangler pattern. You may have an existing system, and you may take a piece of functionality, prove an equivalence on a cloud in a more modern language, as Edward's describing, and you want to be able to turn off a piece of that on the old system and turn on the new system. The challenge that happens for teams is that one of the things that we'll hear is, it still means I'm running two systems for a period of time. There's two sets of costs, there's two sets of things to remember, but one is reducing, the other is increasing. So one of the most prominent challenges that we have is, well, why would I run two systems? But the alternative is, as someone mentioned earlier, no one trusts Big Bang. No one trusts, we will build another system in the background, we run on A, and when we're ready, we turn on B and we switch off A, because that has inherent risk on things that you don't know, the unknown unknowns that could grab you, and that negative impact or risk is significantly greater than running dual systems. So one is a cost and a management and a technical focus. How can I split my teams from the old teams to new teams? When the new teams are really on the rise, what do I do with my old folks? So I think that's one of the most prevalent answers that we get on what we'll do, how would we do that, how would we manage that? And knowing it's there, and you have to tackle it, is part of the governance disciplines life cycle for me. David?
Thank you. I think it's a great discussion, and I think we are talking about, I think, the same concerns that we hear from customers, all three of us here. And the way I view it, at least, and what I've been hearing when we speak to our customers who are doing modernization, is, again, it all boils down to this being a nuanced approach. When you look at modernization as a spectrum of maybe two axes of time and modernization outcome, there's different ways to modernize. You can start from, we talked about that jobbable stuff, like to like, where you just take every single line of code in the source application and convert it as is to modern language. A lot of customers, they see this as basically kicking the can down the road, because you end up with code. Again, sometimes this is a useful pattern, right? It's a multi-pattern approach, right? Different patterns to solve different business needs and technical requirements. But for a lot of customers, this is kicking the can down the road, because you end up with code that's, it's in a modern language, but it's still hard to maintain. It's still a monolithic application. It's maybe like a half measure. And then when you look at the other side of the spectrum, you can completely reimagine your application, moving from batch to real-time processing, introducing a lot of business process changes. That would yield you potentially the best modernized outcome, but takes the longest. And also, it's very hard to gain the confidence if you're going for a complete reimagination where you're changing everything in how your system works and the business processes. You're introducing a lot of variables into an already complex situation. And then you ask yourself, how do I validate if my business rules have changed, if the way I do processing and the way I do transactions has changed so much? How do I validate that this modern system behaves correctly if I don't have the legacy system as a reference? So it is, of course, doable, but it is much more complicated. And if you take those two ends of the spectrum and you kind of hone in on what's the middle, what's the middle of the road approach that is maybe the sweet spot between modernization outcome and speed and confidence and validation, it's to think of it as, as a functional equivalence approach, right? We're saying we will modernize the internals of the application to generate high quality code and readable code and maintainable code. But we will ensure, at least during this first stage, that the outputs are very similar to the outputs from the legacy system, so that we can apply automatic testing for this, right? As entropy is we use this word so many times here, and it's true, it's the enemy of success, right? And modernization, it's not just one bang in terms of taking the whole mainframe and modernizing it at one go, which is rarely successful. It is a process, and nothing prevents customers from iteratively modernizing, starting with, okay, let's take the application, let's modernize the internal code, the internal workings of it. If you think it as a box, we modernize what's in the box, but inputs will generate the same outputs on the mainframe so that you can automate testing. Then once we have that, we can continue to iterate, peel off some business function, move it to more microservices architecture. That is a very reasonable approach to apply to a modernization journey for a customer. When it comes, and I think, I think Edward and I spoke about the functional equivalence part of it. We have two products here. We have Mechanical Orchard's imaging platform and our Dual Run, which approach the same problem, but at a different level. The MO platform allows this functional equivalent testing on a job level, right, as you're modernizing. And then for Dual Run, you can apply it at a whole system level before you go live. So it's the same concept of how to solve the problem, but it's applied at different parts of the modernization journey and the development of the application lifecycle. And just to wrap this up, the more changes and functional changes and business process changes that you introduce into the process, the harder and harder it will get to verify it using automatic tooling when you want to actually verify the outcome. So my suggestion to customers, based on what we are hearing from them, is really to find that sweet spot, start with that, and then incrementally continue to modernize down the road. If you're completely changing your application and the way you do business, it would be very hard to use automatic testing. And we when we created Dual Run, for example, we wanted to give customers the ability to get onto the cloud and off the mainframe as fast as possible. We actually want customers to use Dual Run for the shortest amount of time they can, because it's only meant to validate that the target application is ready to go live into production. The faster our customers can stop using Dual Run, the happier we'll be, because it means they reached the target end state that they want to reach in terms of their modernized workloads.
Yeah, and if I could, I think just to go even more pointedly on what David's getting at, and to answer a question that came in from I believe David Dan Feeney in the question area. On the one hand, we've said, hey, business priorities must dominate. The need for changing the software is actually the primary driver for modernization, and we're advocating that basically. So I mentioned the business metrics and so on. And as opposed to we should modernize because we should modernize. When does that decision get made? Why is IT doing that? Doesn't help the business, no funding, right? As opposed to that situation. On the one hand, we're saying that, modernize in order to change the software more effectively or build more effectively. On the other hand, you hear us saying equivalence, right? So wait a minute, what are we saying? To make changes in software faster, don't change it? What are we talking about? And just to dive even deeper on what David was saying there, no, we're saying change the software, right, to accomplish the business need. What we're talking about, though, is rather than trying to do it in one fell swoop, modernizing a component that is misunderstood or poorly understood, complicated, Byzantine, right, complex business rules, rather than taking that code, rewriting it and changing its behavior and then hoping that works in production. I mean, talk about entropy. That's, infinity times infinity entropy, right? Rather than doing that, it takes two steps. The first step being get it into readable, changeable modern code, cloud native Java being what we've been referring to as a primary example, without changing its behavior. In fact, by keeping its inputs and outputs the same, so the APIs or the data storage is the same in terms of the functionality, and then having got confidence and provable equivalence in that part, go to town, using aggressive development techniques, testing for development, etc., CI, all of that, to aggressively innovate, whether it's functionality or architecture. So the classic example here was referenced by the question, batch, I want streaming. Yeah, great. We're not proposing you don't go to streaming. What we are saying, though, is that take two steps. One is legacy, misunderstood, complicated code that's batch. Make that great modern code that's effectively batch as a second step, and prove it and put it in production and run the systems in parallel. As a second step, innovate on that code base now that you have safety because it's provably equivalent, and now that you have modern code to change, right? That's the concept. Now, two steps sounds like a lot more than one step. Can't we do one step? This sounds like a long two-step process. Well, let me discuss the alternative. And Jobal was mentioned, right? The alternative is what? Either it's a extremely risky, have Gen AI or people or both try and understand the old code, translate it and change it, and let's just stipulate that's just too dangerous, right? Or it's the way we talked about it, or the alternative will be what? What's advocated by many vendors actually today is just change it to Jobal. In other words, do a transpilation approach where it's pretty much line for line, the same number of lines, pretty much the same sort of almost syntax, COBOL-like syntax in Java, .NET, whatever, right? In order to be more confident in the equivalence. I say more, not perfectly. There's still no backup data verification. That's one step, right? Get it on the cloud real quick. And now you're on the cloud with equivalent functionality, maybe, right? Okay, that's one step. What's the next step? Now have people or AI translate that to readable modern code. How? I guess with Gen AI and people, again, crossing your fingers, right? And then on a third step, go and change it to be the functionality or architecture that you want. So, my argument would be no one is going to sit there and say, let's just manually or with AI, take old code we don't understand, modernize it and change it and put it in production effectively. Or if we do, we end up with the same failure rates as before. But, we propose the rules of rewrite that our CEO founded the company on are, if you're going to rewrite something, the first thing to do is make it exactly the same behavior. Change nothing, add nothing, and remove everything you can that's dead, right? Those are our kind of philosophical grounding points. And the alternative is actually far riskier and more steps, I'd argue, right? First, a literal translation, then a translation to more readable code, and then your innovation or re-architecture can begin. Those are three steps that are inherently risky because you haven't got proof at any stage, and it's 3, not 2, right? So that's why I think this notion of equivalence first, then aggressive refactoring is the right one, as long as you can have a provable data set that's exhaustive, comprehensive, that proves the equivalence and lets you ratchet forward progress, right, and not regress. That's how you combat the entropy.
It is a very hard image to argue against. And I know I have a whole load of questions that I won't have time to ask you. So hopefully we will all reconvene to continue this conversation before long. But as we're coming to the end of the session, I want to ask one question that's giving me the heebie-jeebies slightly, but it has come through from our audience, and then see if we can wrap it up for everyone. We have had a lot of forward-looking questions. What happens if I do this? What happens if I don't do this? But we had one question. I'll come to you, Dil, for a quick answer on this. What happens if my client has gone on this journey and now I want to go back? And this is what gives me the heebie-jeebies, the going back part. But can these tools, these capabilities?
Yeah, sure. I'll be really quick. So I think we described a number of steps as Edward just said. And I think one of the things that maybe Dave is far too modest to say is that sometimes our clients are forced into that Jobal step. They've got a contract that's coming to expire. It's going to go up extortionately. They need to get to the cloud really, really quickly. And they think it's the only answer. But then they have all the issues that Edward described. One of the things at a pre-stage to what Edward described was, how do we know what's there? We haven't talked about the scale. So sometimes you hit mainframes, there's millions of lines of code. There's a lot to do. The Thoughtworks have a tool called Code Concise, similarly, which says, let's understand what's there. So a lot of starting points is, we are so frightened, we don't even know what's there to know where to start. And so Code Concise actually breaks some of those things down, and that's what we want to do. So in that question, if I've moved to Jobal and want to go back, you'd want to be able to use a tool which says, what have I got now compared to what I had before? And so some of these agentic tools are allowing you to do that really, really quickly. So I think there is a massive space to be able to do that. And thanks, Thomas, for the question, because it's a really good question. How do we know what we have so we can talk about it?
One of the things that I am experiencing sitting here listening to all of you is, if only I had some of these capabilities, experiences, options, tools when I started this journey many, many years ago, life would be easier, but not easy. I think you have all done, all of our listeners, the courtesy of saying, look, this is de-risked, this is easy, but you still have to make some decisions, you still have to lean in, you still have to make certain commitments. David, I'll come to you with our final question for today, but not for this conversation. Everything we talk about is a decision-making function, right? This technology is there for people to use, but they need to decide to use it. The solutions are there for people to use, but people need to bring them into their business in a way that is material. Everything the three of you have described is available for them to do. So as we're wrapping up, what are your thoughts? Because some people are sitting out there and saying, this sounds great, but I'm still scared. Can I sit it out? And if I cannot sit it out, where do I begin?
That's an excellent question. I think that it kind of alludes, I think, to how we started the conversation, which is no big bangs, start small. Identify services running currently on the legacy system that you can start with. Make it that it's self-funded, so that the ROI from whatever you're modernizing first would be big enough to fund the next step and the next step and the next step in the modernization journey. And I agree that there is concerns and entropy and a lot of fear, because it's a big undertaking for customers to exit a 50-year-old technology that's been serving their business well. So I think that when we combine, I'm hoping like all of the answers that folks heard today from Dil, Edward, myself, it's that we want to reduce the risk. We want to be able to give customers the right tooling to make their best decision, certify the modernized application, give them the reassurance before they actually have to go live that this modernization is successful. You don't want to find things out only after you went to production. I think that combining Thoughtworks expertise in the field with Mechanical Orchard's imaging platform for code modernization, our Duran capabilities, for example, together, it's a force multiplier that gives those checkpoints along the way to give customers the confidence. So it's not a big bang approach. It's an iterative, measurable, with quantifiable ROI approach. You can start with an MVM, with a POC, take one application, see that it works, makes the business case, and then create this journey. And I do think that it's much easier compared to saying, hey, I want a $50 million budget to do a 10-year modernization project. Maybe start with $2 million for a 1-year modernization journey that addresses the 5% of the processes on the mainframe right now that can give you 80% ROI. See success there, and then use that to self-fund the next phase in the journey and the next phase and so on.
I could carry on talking to you guys for a very, very long time. And I know there are more questions that we didn't get time for, but we will be back with this conversation in one way or another. What I have heard for the last hour is that there are tools that we never had before. There are processes that we have refined through years and years of doing this work. There is experience and expertise that can help decision makers with the technology decisions they need to make, with the risk register management they need to do, and with the budget discussions. What we're all out of is excuses to not act. The expertise is there, the partners are there, the tools are there. All we need is the leadership to keep going. And I know that a lot of people on the phone and a lot of people listening to this will be thinking the same. So I'm suspecting your phones and inboxes will be filling with queries after this, which is as it should be. For now, thank you everyone for being with us. Thank you for your excellent questions. And to my fantastic panelists, thank you for your time and expertise.